Hi guys, welcome back. It's Miss Yamasaki. We have so much to do, so little time. I'd like to try and get through 2 sections since this is our last pre-algebra section of the book. We're starting in chapter 5, and so let's get started. You are doing section 5.1 on exponents. It is basic operations with exponents. And we're just simplifying them, okay? In exponential notation. So I should add that as a word. Doing exponential notation. So that means writing it with exponents. So exponential. Boy, that didn't spell it right. Exponential. Notation. Notation means to write. I did it again. This morning. Okay? Exponential notation. Here we go. Okay, so if we have x to the third, this really means x times x times x. Okay, we call this little number up top. Now I want you to write this. This is called our exponent, and that x there underneath the exponent, that is called the base. That is going to become very important because when you're making mistakes, I'm going to ask you, what is the base of the exponent? And the base of the exponent is whatever the exponent is touching to the left. Okay? It's whatever it's touching. Now in this case it's the x, so the base of the exponent is x. Okay? So here's our rules of common bases. That when we are multiplying and they have the same base, see how they both have the same base x, then we add the exponents. Now let's take a look at why that's true. When I have n to the third, that makes n times n times n. When I have n squared, that makes n times n. All together, don't we get n to the 5th power? Count up all those n's. So again, if we use our shortcut rule, which is n to the 3rd power plus the 2nd power, that makes n to the 5th power. So we're going to utilize this shortcut. Because what happens if we have n to the 50th power and n to the 20th power? Nobody wants to write down n to the 50th power. Nobody wants to expand n to the 50th power times n to the 20th power. So we're going to just use our n to the 50 plus 20th power, make sure they look like exponents, and we get n to the 70th. So it's much easier. Pause the recording if you need to continue writing the notes. Okay. All right. So let's try it. Now, if it's in number form, like this, generally they will tell you, simplify. Express using exponents, it says in the directions. Express using positive exponents. And then there's a point where it says do not use exponents. Okay, so here it doesn't say use exponents, so we're gonna simplify it all the way out. So the first thing we're gonna do is we're gonna take the base, 2 to the 2nd power. And then remember, when we multiply our exponents, we really add when we're multiplying with common base, we add the exponents, and so we get 2 to the 5th power. Now, 2 to the 5th power is pretty easy to simplify. And if it's a reasonable amount, I'm going to expect you to simplify. So 2 times 2 is 4. Times 2, that's the third one, is 8. Times 2, I'm doing this on my fingers. So I'll just do it up here. 2 times 2 times 2 times 2. I wouldn't expand it out anymore. I kind of teach that when I'm teaching them in 7th grade, but I'm doing this on my fingers. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so 2 to the 5th simplifies to 32. All right. Now, when we have something like number 2, and look at that second 3. If there's nothing there, it is assumed that it is a first power. So in this case, we're doing 3 to the second power plus the first power. So that makes 3 to the third. And 3 to the third is 3 times 3 times 3, which is 3 times 3 is 9, times 3 is 27. It's not 3 times 3, it's 3 to the third power. Remember, this means 3 times 3 times 3. All right. Now, I said to you, this only works if you have a common base. In this case, what is the base? Is 2 the base? Is the negative the base? Since it's touching the parentheses, the entire negative 2 is the base. The entire negative 2. So if it touches the parenthesis, whatever's in the parenthesis is the base. So this means negative 2 is to the 6th power. I'm going to expand that out. Negative 2 times negative 2 times negative 2 times negative 2. 1, 2, 3, 4, 5 times negative 2. And normally you really don't. But let's talk about our negatives and positives. Every 2 make a positive. So whenever it's an even amount of negatives, it will end up being a positive number. Right? Now, 2 to the 6th power, we know that 2 to the 5th power from above is 32, so multiplied by one more 2, it's 64. I would say that expanding it out, you don't need to do that. So, but let's talk about odd and even amount of negatives. If you have an even amount of negatives, when it's expanded out, then it will be positive. If you have an odd amount, you'll have that 1 extra left over. Okay, pause the recording and try 4, 5, and 6 now on your own. Okay, let's try it. So here we're doing 4 to the 7th. That's a bit much. I'm not going to expect you to multiply that out. But if you got 4 to the 7th, I would accept that. That was a big number, and you really should be using a graphing calculator. Okay, so don't worry about that. Now, again, what is the base? So it's 1/2 to the second power times 1/2 to the third power. So we're adding those exponents. Right? This really means the numerator is to the 5th power, and the denominator is to the 5th power. You could have expanded it out, or you could just do this. Well, let's see what they do. You could do 1 to the 5th and 2 to the 5th. 2 to the 5th. Right? So that would be 1 over 32. So you could have, instead of expanding it out, written after this, it's 1 to the 5th over 2 to the 5th, right? Because everything in there is to the 5th power. Okay, your last problem. They're not all like bases, so we can only use this shortcut for these two. This becomes 2 to the 5th times 3 to the 4th. Okay, and so 2 to the 5th is 32. 3 to the 4th is, I believe, 3 times 3 is 9, and 3 times 3 is 9. 9 times 9 is 81. So when we look at that, we'll let the PowerPoint multiply it out. Okay, please don't turn off the PowerPoint here, because if you haven't seen this, let me tell you, there's a lot of different little rules here. Okay. Let's take a minute, and I'd like to see you guys do 1 and 2. Go. All right, let's check our work. So number 1. All right, so for number 1, we should have had x to the 4th plus the 3rd is x to the 7th. And number 2 should be k to the 5th times k to the 6th is k to the 11th. All right, now when you have a coefficient, coefficients get multiplied with coefficients, like base with like base. So the coefficient of m to the 5th, if there's nothing written there, it's a 1. So really what we're going to do here is multiply coefficients with coefficients normally, and like bases, oops, that should be a 5. Like bases with like base. So the base of the 2 is just the m. It doesn't include the 3 because there's no parenthesis. Okay, so 3 times 1 is 3. You should be writing this example down. And m to the 2nd plus the 5th. So it's 3m to the 7th. Okay, next one. Again, why don't you guys try the next one on your own? All right, let's check it. So hopefully you got 7x to the 8th. All right, the next one gets a little bit different. We've just got to rearrange everything. Don't worry about that parenthesis. It means the same thing. So we're doing a to the 2nd times a to the 3rd. N to the 7th times n squared. And that simplifies to a to the 5th and n to the 9th. Nothing else we can do. Try the next one. Go. Now let's check it. -3, I've got a to the 4th plus the 5th because they're like bases. Don't worry about that parenthesis. So it's -3 and it's a to the 9th since the exponent's base is only the a. Okay? All right. So now if we have a variable expression, just like I mentioned before, we're going to multiply coefficients with coefficients normally and like bases with like bases. You should be writing this down. So when we get 2 times 5 is 10, x to the 3rd plus x to the 7th. I'm sorry, x to the 3rd plus, remember this is what we're doing, x to the 3rd plus the 4th equals 10x to the 7th. Okay, so let's try some. All right, pause the recording and let's try some on our own. Now let's check your work. Remember we're doing coefficient with coefficient, so 8 times 3 and a to the 5th. 8 times 3 is 24, and a to the 5th times a to the 7th. Remember we add those exponents, so that's a to the 12th. Now when you're doing the homework, I do expect you to write the problem, then the answer. Problem, answer, problem, answer. Nobody should just be giving me a laundry list of answers from the back of the book. Okay, next one. We're going to do -3 times 4. -3 times 4 is -12. And a, remember that's a to the 1st times a to the 7th is a to the 8th. Okay. -12 times a to the 8th. Because remember that had a 1 there. Okay, next one. We're going to multiply 9 times -2. Then I've got x squared times x, which is to the 1st power, if there's nothing written, y to the 3rd times y to the 5th. So it's -18. On these, I do expect you to kind of do this intermediary step. Y to the 8th. And the last one, let's do coefficients first. It's 30. A to the 2nd and a to the 1st. Remember, if there's nothing there, it's a to the 3rd. B to the 1st and b to the 5th is b to the 6th. And c to the 3rd, there's nothing else to go with it. Okay? Okay, next. Let's go with, all right, now this is the hardest. I will teach you to the hardest level, but like I likely won't be giving you problems like this on a test. But so teaching you to the most difficult part, it's part of my job because this is going to come up later. So let's take some time and just go over it. Okay, we're just going to simplify this. So 7 times 2 is 14, and we're doing a to the first and a to the third. Let me finish this, hold on. A to the first and a to the second is a to the third and b to the first. Now I've got 5a to the third b. Now notice b is to the first power. These terms are exactly the same. We can only add or subtract if the terms are exactly the same. So if this was like 14a squared b minus 5a to the third b, that would be as simple as we can get. But this is exactly the same as this. So all we really have to do is, subtract our coefficients. So really we end up with 9. 14 minus 5 is 9. A to the third, B to the first. Okay, so I'm going to erase that. Now remember, the only way we can multiply unlike terms. We cannot add unlike terms. Now, see if you can simplify just this part right now. Okay, we always write the coefficient first. How many k's do we have altogether? I have 4 over here, and I have 1 here, k to the 5th. And how many x's do we have? We have 4. Plus 5, k to the 5th, and x to the 4th. So is this the same as this? If it is, we can add those coefficients, -3 and 5. And so that makes 2. And then everything else is the same. K to the 5th, x to the 4th. Try the last one on your own. Okay, hopefully here we are. All right, let's try something else. Quotient power of power properties. Okay, so if we're doing quotient to the power properties, that means division. When we do division, instead of doing division with the exponents, we really subtract. So when we multiply, we really add the exponents if it has a light base. If we divide, we really subtract the exponents. Okay. Now I'm going to show you a couple different ways. So if I were to expand this out, this means x times x times x, right? 5 times. And in the denominator, there's 2 x's. So if I start crossing out, any number over itself equals 1, right? X over x, 5 over 5 equals 1. So really when we're cross-canceling, we're left with 1 and 1 and 1 and 1. And so what are we left with? X to the third in the numerator. And if they're left in the numerator, we say x to the third. If they were left in the denominator, we would use a negative power. But let's just start with this. Okay. Okay, here we go. Now, our quick way is instead of expanding it out, remember, we just take the exponents and we're going to subtract them. The 5th power minus the 2nd power. All right, now, I personally like to use, this is way more, what I'm going to show you right now is more how you're going to be using this. Okay, you're going to be looking to divide common factors. Now, we no longer write divided by, right? I'm going to just use my cross-canceling. So what common factor? It has to be a common number you can divide out of both. So what can be divided out of 10 and 15 is 5. So when I divide 10 by 5, I'm left with 2. When I divide 15 by 5, I'm left with 3. Now, what's the greatest amount of m's that we can divide out? I can take 1 out of the denominator, and I'm not left with 0, I'm left with 1. And I can take 1 out of m to the 4th, and that would be m to the 3rd. So altogether, that makes 2 m to the 3rd over 3. Okay? Now try the next one. Pause the recording. Try the next one. Now let's check our work. Let's do coefficients with coefficients, like base with like base. Almost separated, right? Okay, what can we divide out of the 3 and the 6 and the 18? Is a 3. 3 goes into 3 1 time. 3 goes into 18 6 times. What's the greatest amount of x's we can pull out of the numerator and denominator? We have 2 down here. I'm left with x, right? And if I take 2 out, isn't that 5 minus 2? I'm left with x to the 3rd. So in the numerator, I'm left with 1 times x to the 3rd, but we don't write the 1. And in the denominator, I'm left with 6x. Don't expand it. It takes too much time. Do the cross-canceling like I'm doing. And we're going to need it for Chapter 10. So this is where you kind of get that practice. I'm going to skip this. Okay, so here we go. Let's practice some. Oops. Okay, pause the recording and see if you can try these. Now let's check our work. We've got, since it's dividing, we are subtracting 7 minus 3, and we're left with x to the 4th. I can take 11 out of the denominator and 11 out of here, and I'm left with y to the 8th over 1. So that equals y to the 8th. I don't need to write over 1. I can divide numerator and denominator by 2. I'm left with 1 and 3. I can take 1m out. I'm left with 1. And here I'm left with m to the 7th. So 3m to the 7th over 1. We don't have to write it over 1. Okay, we can take 1a total, because that's the greatest amount the denominator has. I'm left with a to the 4th. I can take 2 b's out. I'm left with b. Oh, no, I'm not. If I take 2 out, I'm left with 1. 2 b's out, and I'm left with b squared. So it's a to the 4th, b squared. M to the 4th up here. I'm left with 1. I can take 1n out, and I'm left with n to the 3rd. And we have m to the 4th, n to the 3rd. Last one. 6 goes into 6 once and into 24 4 times. I can take 4 k's out, and I'm left with 1, and I take 4 k's out, and I'm left with k to the 3rd. And here, I can take 6 out, and we're just left with 1. So my final answer is 4k to the 3rd. All right, let's do our last thing that we're going to be going through. These are the rules of exponents. A lot of little rules. Okay, negative. A negative exponent really implies a fractional or decimal amount. So, when you have a negative exponent, when you have a negative exponent, what you're going to do is drop this down to the denominator, and this becomes the exponent. But since it's 1, we don't usually write that. So here, I'm going to create the fraction. the base drops down, and this is to the first power. It becomes a positive exponent and 1 up here. I'm taking we're reciprocating it, right? So it really becomes 1 over 3. So number 2, if this is what it is naturally, it's going to be 1 over 5 to the first power. The next one is going to be 1, right? If this is naturally, everything's naturally over 1. 1 over, notice I'm taking the reciprocal, 1 over 4 to the second power, but that's not simplified. So I have to go 1 over 8. So one more time, a negative exponent is really a fractional amount. 1 over 6 squared, which equals 1 over 36. Okay, when we get the fractions, we're just going to reciprocate it, and then everything in there is to that power. So to lose the negative, I'm going to take the reciprocal, and it's to the first. So that equals 5 over 4. Again, with the negative exponent, if I want to lose the negative exponent, I'm going to take the reciprocal, 3 squared, I don't really need the parentheses, 3 squared, lose the negative exponent over 2 squared. I'm reciprocating it, flipping it over. And so that's 9 over 4. We're not going to follow the pattern, we're just going to practice. Okay, so 3 to the 0 factor, 0. If I have, forget about this. I don't like this explanation. Let me do this. Let's go about 3 to the 0, okay? Let's say we have 3 to the 4th power over 3 to the 4th power. What that means is 3 times 3 times 3 times 3, right? And this is 3 times 3 times 3 times 3. If I am, that becomes 3 to the 4th over 3, oh, sorry, not doing, I'm going backwards. Now let's cross cancel. Any number over itself equals 1, right? So I can cross cancel and divide a 3 out and a 3 out. I can divide a 3 out and a 3 out, and I'm left with 1. Same thing here. And when I add those all up, don't we get 1? So let's use our shortcut method. 3 to the 4th power minus the 4th power. That equals 3 to the 0. And didn't we already say that this equals this? So this 2 is equal to this. Anything that's to the 0 power, 100 to the 0 power will equal 1. Because what it means is you've expanded everything out and you're cross-canceling everything. There's nothing left but 1. Anything to the 0 power. X to the 4th over x to the 4th is equal to x to the 0, which equals 1. Okay? So, okay, let's see if there's, okay, so right away it says express using positive exponents. So we are going to create a fraction because we know negative exponents. We drop the base only. The base is the x and make it to the 5th power. Remember, this is like over 1, right? When we take the reciprocal. Okay, I'm going to try the next one with you. You should be writing these examples down. Now notice, the only thing that drops down, what is the base of that exponent? Right there, that y is the only thing touching. So y to the 3rd comes down, 5 stays up. Now here, what is the base of this exponent? Everything in the parentheses. So everything in the parentheses comes down, and everything is to the second power. Right? So now I've got 1 over 3 to the second and m squared. That means 1 over 9m squared. Better yet, let's look at it like this. 1 over 3m times 3m, which makes 1 over 9m squared. Okay? Okay, pause the recording and try the next 3 on your own. All right, let's check our work. So what goes to the denominator is just the, okay, remember, we're here. The only thing that's reciprocated is the base of that exponent. So since a is to the negative 1 power, that's what drops down. And 6 stays high. What drops down? Everything. Stays in the parenthesis until I simplify it. And so we get 1 over 2 to the third power is 8, and a to the third. And now, very important, remember it's 1, so I'm going to go 1 over c squared d to the third. Okay, so we've gone over multiplying with a common base, dividing with a common base, 0 power, and positive exponents. I'm going to stop here, and that's it for our day.